Hello students, let's look into some examples, some problems. Okay, the first one is we have an op-amp configuration and here are the value of Ri and Rf is given. Determine the value of Rf required to produce the closed loop gain of minus 100. So it is understood that since the input source is connected to the inverting terminal, this is an inverting amplifier. So the voltage gain is given. Then the equation for gain is ACL is minus RF by RI. Then ACL is given, RI is given. We can directly apply into this equation and the value of RF is 220 kilo ohm. Okay. Another problem is we have another picture configuration circuit, determine the output voltage. So this is also, so first you have to consider or you have to check whether this is an inverting or a non-inverting amplifier. Since the input is connected to the inverting terminal, this is an inverting amplifier and the equation is minus Rf by Ri. Here the values of Rf and Ri are given and we can calculate gain. Okay, so from this picture 200k by 2k we will get the value as minus 100. And the question is to determine the output voltage. So the equation for gain is equal to output voltage by input voltage. So output voltage will be gain into input voltage. Here input voltage is 2.5 millivolt. So applying we will get the output. Next problem. Find out the output voltage for the circuit shown. Okay, so here you have to draw the output voltage. Here instead of connecting the voltage cell or instead of showing the voltage source in the circuit, the input graph is given here. That means this is a input having voltage 0.5 volt. Clear? So the equation for gain will be minus Rf by Ri, which is equal to minus 1. So minus 1 means output voltage is equal to input voltage. So if it is 0.5 peak voltage, then for the output voltage will be same, but since it is an inverting amplifier, it will be 180 degree out of phase. Clear? So the next problem is find the output voltage for the given circuit. And here the input voltage is 0.5, that is 0.5 positive and 0.5 negative. So it is actually 1 volt. So we are applying a 1 volt AC signal to the inverting amplifier. Then what will be the output? So from this picture it is understood that minus Rf by Ri is 40. Therefore the gain is 40. Then what will be the output? The output will be actually input into gain. So input is 1 into 40, the output voltage is 40. But the problem is that I have told you that if we are giving a supply voltage V supply, then there will be a saturation voltage V supply plus or minus 2. That is, since it is 15 volt supply, the saturation voltage will be plus or minus 13. Okay, so plus or minus 13 means plus or minus 13 into 1 volt. That will be the possible input voltage that can be given to a op-amp. Clear? So here the output voltage, the maximum output voltage that can be obtained will be plus or minus 13 voltage, because after that the op-amp will be driven into a saturation region and it will become non-linear. Clear? So the output voltage will be like this. After 13 voltage, the remaining voltage will get clipped. Okay, so here since it is inverting amplifier, the output will be 180 degree out of phase, but after 13 volt it will be clipped. Okay. So next in this picture we have to find out the closed loop gain, the input impedance and the maximum operating range. Slew rate is given. Slew rate is actually out of syllabus. So the closed loop gain will be minus Rf by Ri. Input impedance for an inverting amplifier Zi is approximately equal to Ri. Okay. Then okay, that's fine. Next, check this example 25.31. It shows that in an inverting op-amp, closed loop gain, find the closed loop gain if R source is 0 and R source is 1 kilo ohm. That is the source, the resistance of the source. Okay, actually we consider the input, the impedance, the resistance of the source as 0. But if we have the resistance for the source, then the equation will be different. Okay, so without any internal resistance, if R source is 0, then ACL will be minus Rf by Ri. But if you have any resistance, if you are considering the resistance of the source, then then it is understood that this our source and our Ri are series to each other. They are in series. So the equation will be Rf divided by, instead of Ri, it will be Ri plus R source. Okay. Only that is the difference. Clear? Now we have non-inverting input. Same problems. In a non-inverting input, Vin is given 120 microvolt. Then ACL will be 1 plus Rf by Ri and output voltage will be ACL into Vin. Okay. Okay. So in this picture, we can draw. Let's draw the output diagram. So here output voltage will be 1 plus Rf by Ri, which is equal to gain will be 6. Then output voltage will be ACL into 1 minus 1, actually 2 volts, so 6 into 12. So if you are drawing 12, it will be plus 6 and minus 6. Okay, and they will be, input and output will be in phase with each other. Clear? So nothing much. Then if you have a multi-stage amplifier, then find out the individual gain and just multiply A1 into A2 into A3. Okay. Next, we have to look into differentiators and integrators. Okay. So, about a integrator. Check this example. This figure shows an op-amp integrator and a square wave input. Find the output voltage. Okay. So here the value of R and C is given. So V input is also given. Then we have to calculate the output voltage. First we can calculate minus 1 by RC integral VI into dt. Minus 1 by RC. RC is 100K into 100 microfarad. The value of R into C will be 1 second. Okay, so this minus 1 by 1 will become minus. So output voltage will be integral of VI dt. Okay, so from 0 to 1 second, the input voltage is 1 volt. Okay. So here 0 to 1 second, input voltage Vi is 1, integral dt become t, and t is also 1, so the output voltage will be minus of 1 into 1, which is 1 volt. Okay, and it is understood that the output is directly proportional to input, which is the equation of a straight line. So from 0 to 1 volt, the output is minus 1 volt, which will be a straight line. Clear? Now next one is from 1 to 2 volt. 1 to 2 volt, Vi is minus 1. So minus of minus, it will become plus 1. So the output will be plus 1 volt. Since it is in minus 1, plus 1 will be like this. Okay. Again for the next from 2 to 3, again it is positive. So it will be a negative ramp, then a positive ramp, like this. Fine. Actually the output should be plus 1 volt, but since we are starting from minus 1 volt, minus 1 plus 1, it will reach 0 volt. Okay, so that is what. Let's look into another example. Determine the lower frequency limit or the critical frequency for this integrator, and we have the equation for critical frequency 1 by 2 pi RFC. Value of RFC, everything is given. Applying, you will get the value. Okay. Now look into this example. Determine the rate of change of output voltage in response to a single pulse input to the integrator circuit. Okay, that is, you have a single pulse input signal and an integrator. What will be the output? Okay, so here the output voltage is minus 1 by RC integral Vi dt. So first question is rate of change of output voltage. Rate of change means dV out by dt is equal to, if you are taking a differential, then integral will become minus 1 by RC into Vn. Okay, so dV by dt is minus 1 by RC into Vn. That is what V out is equal to integral of this. Clear? So the question is find out the rate of change of output voltage. So dV out by dt is minus Vn by RC. Value of R given, C given, V is 5 volt. Applying, we will get it as minus 50 kilovolt per second. Usually we write it in millivolt and microsecond. Actually no need of writing like this, but we can write. Okay. The next question is draw the output waveform. So to draw the output waveform, actually we have to understand what will be the output voltage, but this time is not given here. In this problem, the time interval between two pulses not given here. Okay, so in this problem, I am taking it as 100 microsecond. Since we are writing it in microsecond, I am taking it as microsecond. I will tell you why I am writing like this. Okay, so V out by dt is equal to minus V in RC. Then V out will be minus 1 by RC integral V in dt. That is minus 1 by RC into V in is 5 volt into dt is 100 microsecond. Then the output voltage will be minus 5 volt. Okay. So if you are not taking it as 100 microsecond, if you are taking it as 1 second, the output voltage will be very high and it will be difficult for us to plot. Okay. So for that, usually in problems this time interval will be given, and here it is not given, so we are taking it as 100 microsecond. Clear? So here, since I am taking it as 100 microsecond, either you can directly apply into this equation, or here they have written it as V out is equal to dV out by dt into dt. Okay, so dV out by dt is minus 50 millivolt by microsecond into dt is 100 microsecond is minus 5 volt. Clear? So actually the output voltage is minus 5 volt, but what will be the actually how this output looks like? Okay, since this is a constant voltage, the output voltage will be V in is actually a constant, but since it is V out is directly proportional to V in, it will be a ramp, a straight line. So from 5 volt to 5 volt from 0 to 100 microsecond, that is when 5 volt voltage is a constant, the output voltage will be minus 5 volt, but it will be a negative ramp. Clear? After that, V input is 0, output will be also 0. Okay. In this picture, so here in this picture, input is given. Sorry, we have to draw the output. Okay, so in this picture, output voltage will be minus 1 by RC integral V in into T. So RC V in T. Actually, the value of T is not given. The question is, how long does it take for the output to reach saturation? So saturation means output voltage is, saturation voltage means plus or minus 13 volt. Okay, since supply voltage is 15, saturation is 13. So the question is, how long will it take to become the output voltage at 13 volt? Okay, so in this problem I am taking output voltage as 13 volt. Okay, it can be plus 13 or minus 13. I am taking this as 13 volt. Then applying all other equation, minus 1 by RC V in, we will get the value of T, and T is 2.6 second. Clear? So these are the problems related with integrator. Next is differentiator. In this picture, this is a differentiator. Okay, because it is feedback resistor and we have capacitor. Find the output voltage if input goes from 0 to 5 volt, 0 to 5 volt in 0.1 millisecond. The question is, output voltage is going from 0 to 5 volt in 0.1 millisecond. Not this time period. The time period taken for change in voltage to reach from 0 to 5 volt is given it as 0.5 millisecond. Okay, so find the output voltage, and output voltage for a differentiator is minus RC dVi by dt. Value of RC is given, dVi by dt, that is change in voltage by change in time. Change in voltage is 0 to 5 volt. It's actually a positive end, right? 0 to 5 volt. So the increase in voltage change in dVi is 5 divided by the time taken for it is 0.1 millisecond. So dVi by dt is 5 into 10 raised to 4. So output voltage will be minus RC dVi by dt. The output voltage will be minus 5 volt. That is, within this 0.1 millisecond, the output voltage will become minus 5 volt. Okay. Then what will happen after this 0.1 millisecond? After that, the input is constant. If the input is constant, output will be 0. Okay. Again, for the next time period, for the next 0.1 millisecond, the input is decreasing from 5 to 0. So actually this dVi by dt will become negative because the change is from 5 to 0, 0 minus 5. So this will become negative and the output will be negative. So you will get a positive ramp. Clear? So this will be the output of a differentiator. Another one, determine the output voltage if input goes from 0 to 10 in 0.4 second. Direct problem, output is minus RC dVi by dt. RC given, dVi by dt is, it is changing from 0 to 10 volt within a time period of 0.4. So 10 by 0.4, you will get it as minus 0.55. Another one, input is given, determine output. So here actually for the first 0.2 second, input voltage is steadily increasing. It's a straight line. Okay. So the output will be minus RC dVi by dt. Here 0 to 1 volt divided by time is 0.2. So minus RC dVi by dt will be 1 minus 0 by 0.2. The answer is minus 5. So within this 0.2 second, the output voltage will be minus 5 volt, which is a constant. After this 0.2 second, input is constant. If input constant, output will be 0. Okay. So this is, these are some problems associated with differentiators and integrators. Thank you.